Hello, this is Dr. Scott Dennstaedt, founder of EZWxBrief, your best online source for aviation weather and education. Welcome to episode 9 of EZWxChat, a program to talk about anything related to aviation weather. I'm going to focus on the Storm Prediction Center Convective Outlooks. There are several out there that are very useful to pilots to basically look at that big picture planning. I want to cover those today in the EZWxChat program. I want to also talk a little bit about the convective probabilities, specifically looking at the more likelihood of convection, and relate that to the thunderstorm probability that we show in the EZWxBrief application. So the Storm Prediction Center's primary job is to predict severe weather. That would be severe thunderstorms, they do even fire weather to determine where the most likelihood of significant fires are. They also look at even severe wintertime weather, such as really serious freezing rain events or even heavy snow events. They issue outlooks, but they also issue other products that are more recent products in the sense of they are things like severe thunderstorm watches. They don't issue warnings. Those are done by your local weather forecast offices, but they issue watches in what are also called Mesoscale Discussions, kind of the front lines of severe weather when it's expected to occur. Now let's just do a quick summary of what the Storm Prediction Center kind of considers severe weather. Now severe weather, it looks at three basic items, and that is severe weather in terms of strong straight line winds near the surface. It also looks at the potential for tornadic thunderstorms or tornadoes. And lastly, large damaging hail. You notice that lightning and precipitation intensity is not part of that criteria. So it's basically strong straight line winds, tornadoes, and the possibility of large hail. So the Storm Prediction Center spends most of their time not worried about general thunderstorms per se, although we're going to see that the general thunderstorm outlook is very useful. But in most cases, they're really trying to pinpoint where that severe weather will be located. Now the stakeholders are anywhere from the general public to aviation, although this is not specifically an aviation-centric product, but aviation essentially can use this, as well as anybody who does any kind of planning for weather kind of events. The Storm Prediction Center spends most of their energies on what's going to happen over the next, let's say, 6 to 12 hours, but they do provide outlooks that go out even as far as 8 days, and we'll show you those in just a bit. So the first thing that you will look at typically when you're trying to figure out, am I going to run into any kind of convective weather? Specifically, am I going to run into any areas where there's a possibility of widespread thunderstorms or widespread areas of convection? Now we have to distinguish between convection and thunderstorms. Essentially, anytime you have convection doesn't mean you necessarily have lightning, and lightning is a requirement to call something a thunderstorm. So even very heavy rain showers can be a convective kind of situation. But in general, the Storm Prediction Center worries mostly about what's happening over the continental or conterminous U.S. here, and does not forecast necessarily for Canada or Mexico, or even further out along the oceans. As you can see, that the product really ends pretty much right at the coastlines. So there are four basic outlooks that you can see here, and in EZWxBrief I show them as the day 1 convective outlook, and you'll see a day 2 convective outlook here, as well as a day 3 convective outlook, and there's a 4 to 8 day convective outlook, and it's 4 to 8 day convective outlooks in a loop here, so you can see the possibility. Now, the biggest difference between this particular outlook and the others is that this doesn't predict general thunderstorm activity. It only shows you where the possibility of severe weather might be located. And for this particular case, the Storm Prediction Center says the predictability is too low to forecast any severe weather. Remember, severe weather is very rare in general. So when's the last time you've had a tornado kind of run through your backyard? Again, it's rare. I mean, certainly there are many storm spotters out there that see tornadic thunderstorms and such, but generally speaking, severe weather is pretty low probability for that to happen on any given day. So to think that forecasters can predict this out more than a few days is not certainly. Forecasters don't have the tools available to them to be able to do that. So the only thing they can provide is some kind of general guidance for the possibility that a weather system and a signature is occurring that might produce severe thunderstorms in this particular case. So let's take a look at the convective outlooks, and then we'll get into using the enhanced resolution thunderstorm outlooks in just a bit. So let's just start with the day one outlook. Day one outlook means today. Day two means tomorrow, and day three means the day after that. So day one is today, so this basically shows you where they expect in the period, the valid time that you see here. So it's from 1630 Zulu today all the way through 12Z tomorrow. And I will say when this is initially issued, it runs from 12Z to 12Z, so it's a 24-hour period, and you'll see that when we look at the day 2 and the day 3 outlook. It's basically a 24-hour period. And so anywhere you see color shown on here in that period that's identified in the valid date timestamps here, essentially will tell you where they expect at least a 10% or greater chance of thunderstorms occurring. So the light color green that you see here is basically just general thunderstorm activity that would potentially occur in that 24-hour period. And then the other colors, whether it be a darker green, yellow, kind of this goldish color, red and magenta, all show you the possibility of severe weather. So we see here in the Gulf Coast states from Florida all the way through Texas, you can see there's a marginal risk of severe weather. And then of course along the coastline here from down near Charleston, South Carolina, all the way up through Elizabeth City in North Carolina, we are dealing with the possibility of a slight risk of severe weather. Now, it doesn't tell you whether it's going to be related to hail, tornadoes, or strong straight line winds. Could be all three, could just be essentially one. But at least it alerts you to the area, and we'll see how to explore this to look further. Now, the biggest difference between the different colors are really looking at intensity, size, and number. So, for instance, when you're dealing with something as significant as a high risk, for instance, when it comes out, in fact, they don't show anything in terms of high risk that only will ever appear on the day one outlook. You won't see that on the day 2 or day 3 because it's almost scientifically impossible to predict the possibility of extreme weather like that more than a day in advance, so they just don't do it. So moderate risk you might see, but not a high risk on days 2 and day 3. But for day 1, let's say there was a high risk shown out there and you saw a magenta color. What that tends to mean is that you're going to be dealing with a lot of really significant thunderstorms. I mean, a lot of them, and they will produce a lot of severe storm events, such as a lot of large hail events, wind events, or even tornadoes. So in this particular case, you'll be looking at possibility of the on the enhanced Vegeta scale. You'll be looking at like an EF 3, 4, and 5 tornado, and potentially lots of them with a high risk. hail may be on the order of softball size hail, and there may be lots of reports for that kind of hail event. Or strong straight line winds well in excess of 60-knot wind gusts, and there'll be lots of reports. And as you go down the scale to moderate, enhanced, slight, and marginal, you get less and less of that. So for instance, a marginal, you might find one or two EF1, EF0 tornadoes that form. You may have a few hail events of 1-inch diameter or golf ball size hail that occurs. And then you may have a few wind events with a marginal risk. So essentially, you're dealing with more intense weather the higher it goes in terms of the categorical outlook there, or more events of those with a larger in terms of the sizes and danger of that particular event. So as a pilot using this product, again, it's not an aviation-centric product here. As a pilot using this product, this is just going to give you the big picture. So even though this begins at 1630Z and goes all the way through 12Z, some of this severe weather might be associated with weather that's going to occur towards the latter part of that period. You really can't tell per se using this particular product. But what you can tell is essentially that anywhere you see white, there's a really low chance, not that there's a zero chance. Certainly I could be flying through Tennessee or Kentucky here, and I might come across a couple of interesting cells and maybe even a thunderstorm or two associated with a weather system that's not necessarily going to be a well-organized weather system per se. So it's not saying that you won't see any possible convection in those white areas, but the chances are very low. So if I'm making a trip from Chicago down to Nashville, likely today won't be a problem with respect to having any kind of significant convection. And in general, that's probably one of the best ways to use this kind of a tool, because you don't really know per se where, when you're going to deal with convection that's shown here in the green or even the yellow area. So for that kind of a situation, you're going to have to drill down a little bit and use what's called an enhanced resolution thunderstorm outlook that provides some of that information. Now with each one of these convective outlooks, you also have the ability to see essentially what the probability of tornadoes, wind, or hail events may occur. So if we look at one of those, for instance, this is basically saying that they don't expect any of the severe weather to produce much in the way of tornadic thunderstorms. So if we were to visit the wind, sure enough, most of the severe weather that we see here off the coast, the South Carolina, North Carolina coastline, has a greater chance of having a wind event. So this is, we're dealing with winds that are in excess of 50 knots or greater in around areas of thunderstorms that do develop. And then of course there's also the possibility of hail. So for the most part, when you look at this event that's here, it's occurring in eastern North Carolina, what you're seeing is mostly a hail and wind event associated with those severe thunderstorms. And the numbers can actually get pretty high here, even up to 30 and 45%, which would be really significant. And they'll crosshatch those areas as well, which has a specific meaning in terms of the fact that there's a greater chance or likelihood that you'll see severe weather there. So let's take a look at that and bring this over here, and we'll look at the Storm Prediction Center's website. And here's the day 3. So if we look at that, for instance, and we look at the probabilistic forecast here, you'll see it says here at the bottom, this is not included on the EZWxBrief image per se, but a hatched area would mean 10% or greater probability of significant severe weather within 25 miles of any point. So you pick any point here within 25 miles, there's a 10% or greater chance that you'll see something. So if you're in one town and you have a buddy that's in another town that's within 25 miles, most likely one of you are going to see some kind of a severe event, whether it's going to be wind related or it's going to be hail or tornadoes. Most likely that's what will happen when they cross-hatch those areas as well. In addition, although it's not presented here with EZWxBrief, there is a discussion that goes through and provides you with a lot more information. So what I'll do is I'll do my briefing with EZWxBrief from beginning to end, and I may go back here and reread some of this, because sometimes this will tell us and give us a better idea of when something is going to happen. Like Thursday morning, storms may be ongoing across Minnesota and Iowa. So it kind of gives you an indication that there may be some nocturnal convection that occurs Wednesday night. So it may further kind of qualify when that's going to occur. And of course, this is meant as a forecaster to forecaster discussion, so you're going to see a lot of very significant technical terms like over 2,000 joules per kilogram of most unstable cape, and the effective shear is forecast to be around 50 knots. Well, of course, that doesn't make a lot of sense, and to most pilots out there, it's important for meteorologists that are looking at this as well. The Storm Prediction Center, forgot to say, is located in Norman, Oklahoma, and this is broadcast out and available to all meteorologists around the country. And they will tend to read through the summary of what's going on for that particular convective outlook. So they can factor that into their local weather forecasts as well. Like I said, there's the day 1 and then the day 2 convective outlook. For day 2, and this is looking at a 24-hour period from 12Z to 12Z, only showing a marginal risk here. And then we'll look at day 3 convective outlook, which we were just looking at here, which again shows a slight risk. And again, the discussions will go in and try to explain what's going on here in terms of the meteorological aspect of things, whether there's an upper level weather system that's enhancing this, and kind of give you the magnitude of what's going on using that discussion. And finally, there's the day 4 to day 8, and I mentioned this earlier, primarily designed just to show you where the possibility of severe weather is, and most of the time its predictability is too low just because it's really difficult to forecast severe weather this far out without having really good signature. And even then, even if they do predict that, that sometimes can be off by 12, 18 hours. So what they were predicting on day 4 may end up turning out to be more towards day 5 as the weather system evolves. Then the other component to the Storm Prediction Center is when they issue severe thunderstorm watches. And sure enough, we saw that there were some possibility of severe weather here along the South Carolina and North Carolina coast, and sure enough, they've issued a severe thunderstorm watch. And if it was a tornado watch, which we know that tornadoes are not expected here, it would be a red kind of polygon. Ultimately, this just shows you that there was a watch issued. This doesn't necessarily mean that severe weather is occurring at this time. Typically, the watches usually try to go out before even the first towering cumulus starts to develop. That doesn't always happen. Sometimes weather develops really quickly and these systems or these watches come out. But watches are just that, basically to tell you simply that there is the possibility, not that there is severe weather occurring at this point in time. And when severe weather does occur, that's not the job of the Storm Prediction Center to produce warnings. Your local weather forecast offices that are located around the country, it's like 123 of them, I believe, located across the country, will be the ones that issue severe thunderstorm or tornado warnings for the local area. So the watch is basically to say, hey, there's some possibility that something might occur in terms of severe weather, and then the local weather forecast offices take over at that point to further pull in their expertise, looking at radar depictions, looking at storm spotter information. Even Twitter sometimes helps them get more information about what's going on. And most of those severe thunderstorm warnings go out usually as that weather is evolving and happening. So they'll get a radar signature that shows maybe a tornadic thunderstorm, or they'll look at vertically integrated liquid, and that may show the possibility of hail. And they'll also look at the radial velocity, the Doppler portion of the radar, to determine maybe strong straight line winds are occurring, but they're also using surface observations from the various different airports, the ASOS and AWOSs, to also help with that determination. So that's your local weather forecast offices that take over essentially the watches there. Now, you could even have severe weather occur outside the watch area. That's certainly possible. That happens quite a bit, but this is really talking about more well-organized areas of severe weather. The Storm Prediction Center also concludes this latest activity. It's really hard to see here, but ultimately it'll show you the depiction of the radar depiction overlaid kind of to show you that where the cells are occurring. Of course, it'd be better for you to actually look at a more well-defined radar depiction like we have here with the MRMS composite radar reflectivity, where we can then evaluate kind of what's going on here. In fact, this also shows you that where the location of severe thunderstorms are, and again, these are issued by your local weather forecast office. So the Wilmington Weather Forecast Office issued a severe thunderstorm warning here, probably also out here as well. It's pretty close to the Charleston Weather Forecast Office, but ultimately they were issuing these yellow advisories for a possible warning, or a warning for a possibility of severe weather. And then you see these are more marine-oriented advisories going on out here off the coast. And you see here further south, you see this here, there's definitely some areas of thunderstorms that producing some severe weather, as well as some marine advisories going on out here. We know that severe weather is occurring at that particular point in time. And so when the day one convective outlook was issued, there may not have been any clouds or any precipitation at that particular time, and this is basically has developed over a period of time. So you can see here earlier today, we're looking at, let's see, the time is about 17Z. We look at this, we can see that most of that weather kind of developed around 18, 19Z or so, and started to develop at this point and producing the weather that eventually triggered severe thunderstorm warnings to be issued. But the watch came first. So the watch was issued, and at that point that alerts the local weather forecasters plus the public, and you've probably gotten messages or emails or sometimes texts to be alerted to severe weather when that occurs. And we'll take a look at the other component to this very quickly here under the Storm Prediction Center. Well, I want to also mention here the Mesoscale Discussions. Mesoscale Discussions are kind of a precursor to the severe thunderstorm or tornado watches. And ultimately, red ones don't mean tornadic. They just mean that they are associated with convection. If they were blue, they would be associated with wintertime weather for Mesoscale Discussions. And so these are discussions where you can go on the Storm Prediction Center website and read the details of what's happening. Normally the goal is to have these issued first, and they usually will tell you, and let's go ahead and see if we can find a case of a discussion going on here. So if we go over to the Storm Prediction Center site and we look at Mesoscale Discussions, and we can click on any of these and it will bring up the discussion. And this is a forecaster to forecaster language, so you're going to see a lot of details here that you probably don't understand, but in the end you can maybe glean for, in this particular case, find out maybe when things are going to occur and what kind of things are going to happen. In this case, the probability of a watch issuance is 5%, so it's really unlikely that they'll issue a watch associated with that. But if in the event that there was the case, if we looked at an earlier mesoscale discussion here, let's see if we can find one here for the previous ones. So this one here was the one that they issued prior to the watch, and it will give you again the meteorological kind of signatures that are occurring and the reason why they're concerned about this particular area, and this said severe thunderstorm watch likely. And when this is really happening quickly, sometimes the mesoscale discussion gets issued even after the watch when things are happening very, very quickly. In that particular case, you'll see the watch appear, and then usually they'll follow that up with a mesoscale discussion after that fact. And so the last convective outlooks are what we call a enhanced resolution, and the resolution that's being enhanced here is the temporal or time resolution thunderstorm outlooks. Now these are just purely thunderstorm outlooks, not really severe weather per se, but they come in 3 different levels here. And so let me see if I can find one that will provide us with a 70 percentile there. Probably won't. And unfortunately, nothing's showing here today with that. But the time frame here is much nicer, and that is these are only issued for today, not issued for tomorrow, but they're from 16 to 20 Z, so it's a 4-hour period unless you get into the later one, which is a more 8-hour period here in the overnight hours. But ultimately you can see 12 to 16 Z, and it'll go 16 Z to 20 Z, and then 20 to 0 Z, and then 0 to 4 Z. Have to be careful when you wake up early in the morning, especially on the East Coast. These last 2 here may not actually be for today. They don't issue the 0 to 4 Z. Let's see when they issued this. This is issued at 1630 Z. So you might find that some of the later ones here are the day before, so pay attention to that date timestamp that's occurring there. And certainly that's true of the 04 Z. That's also issued here at 1630 Z on the 15th. So in this particular situation, when you wake up in the morning, usually you'll have the 12 Z all the way through to typically the 0 Z, and then the 4Z and the 0 to 4Z and the 4Z to 12Z will be available later on. So just, again, be careful about that. So when we look at these, we're just basically looking at the probability of thunderstorms in that 4-hour period. Now we got a 4-hour period, which is pretty short period overall, and then they will usually have 3 different contours here, gradients of contours, and that is a 10%, a 40%, and also a red 70% will potentially show up for those situations that have a very good chance of occurring. So again, if you're looking through and trying to figure out, can I kind of fly down through from Baltimore down to Wilmington, this gives you a good indication that, that maybe early on in the day that might be totally 100% possible. So from 12Z to 16Z, it's pretty likely that you won't find any thunderstorms along that route, but if you wait too long, you end up in the 16 to 20Z range, or even later than that, 20 to 0Z. A trip to Wilmington, North Carolina from Baltimore is going to be a challenge overall. It helps kind of give you a good first impression of what's going to happen throughout the day. So you wake up in the morning, you have this available to you, can better understand. And there are other products in EZWxBrief that go out further in time that have a pretty good temporal resolution, all under this thunderstorm probability forecast. And in this particular case, you have, for instance, the 3-hour thunderstorm probability forecast, which goes out to about somewhere around 3.5 days in the future, and you can get, again, a better understanding. And this kind of should line up pretty well with the thunderstorm outlooks, because ultimately forecasters are using those thunderstorm outlooks, using this product to create those thunderstorm outlooks as well. in addition to looking at other data. So this becomes a really important product to kind of hone things down further out in time. So I also want to take a look at the thunderstorm. So let's go to view the airport weather. And so I want to also look at how in EZWxBrief we characterize convection in thunderstorms. You'll see on the meteogram, you'll see a time series at the bottom, and it will have precipitation probabilities here, but it also has convective potential. And in the convective potential, you'll have two parameters showing. One is the thunderstorm probability, and the other is essentially a convective potential, which in this case shows really as none. So it's really anything that's less than about 10% means that you probably have very little chance. This is showing a convective potential, not really a whole lot there, and I'll explain some of the details in a bit. So let's look at KILM Wilmington International, because we know there's some convection going on out there. And we'll look at the day one outlook. And sure enough, you see under convective potential here, you'll see the convective potential initially was very low, and we saw how that about 19Z or so things started to really heat up in that area. Again, this is for the airport. So Wilmington Airport may, we can actually look at that and see what's happening with the METARs associated with Wilmington. And yeah, there's got some, so around, let's say 18Z or so, nothing was happening. It wasn't until about 1846 that thunderstorms of vicinity start to pop up, and that's in the vicinity. The forecast that you see here in the time series is primarily at the airport, so kind of within a 5 statute mile area that we're looking at here. So ultimately, this is still in the vicinity, but around 19Z or so. But what we expect is that the probability is going to go up, so the thunderstorm probability is going to go up, and the convective potential is still essentially showing as low here. Now the convective potential can go up to medium, high, and even very high. So there's two kinds of situations that occur. First of all, we know that all thunderstorms are produced through convection, so there's no doubt about that. So we know that a square is a rectangle. So in this particular situation, there are two kind of things to kind of think about. Now, number one, what is the chance that any thunderstorms or any convection will occur? What's the likelihood that convection will happen at a particular time? And then, what are the chances that some of that convection could be thunderstorms, could actually have lightning associated with them? And so that's really what we're trying to show here. The convective potential here is showing as fairly low, although again, there's also very low as well, so low. And the simple fact is that that there is a pretty good chance, 34% chance showing here, that you will have lightning. So maybe 1 out of every 3 areas of convection will contain some pretty significant amount of lightning that it could impact the terminal area itself. So we have to think about, why is this, we know we've got severe weather out there. And you think, well, if there's severe weather, there's got to be a really good chance of having the possibility of having convection. But as we know, and we can even see it in the terminal forecasts here, as we know, we certainly have the possibility that between 19 and 22Z at Wilmington, there is going to be some thunderstorms and rain. Right now, we're just seeing thunderstorms in the vicinity. So for this convective potential, EZWxBrief is really concerned what's happening right in the terminal area here. So if for some reason a lot of the convection just moves around the Wilmington terminal area, really doesn't impact it, that's kind of what the fact that we're dealing with a low potential. EZWxBrief is kind of thinking that there will be some chance that there will be some convection in and around that region, but there is still a fairly low chance. We may escape not having any thunderstorms, so we would have to look later to see if there were actually any thunderstorms impacting that region. And as the weather does evolve, EZWxBrief gets updated every single hour. You may see some changes to this overall with time. So this may end up catching on to the fact that there are definitely some convection that has developed, and the probabilities may go up for thunderstorm probability as well as the convective potential. But right now it's showing here as being on the lower side. Now if we look at another airport nearby, let's say ECG, I think it is, Elizabeth City, so a little bit further to the north. They had some thunderstorms in the vicinity earlier on, the case may be, but we can also see that yes, we had again more along the lines of a low convective potential with a 17% probability that some of those will contain some lightning in those storms. Let's see, we can also look at a couple of other stations here. Let's go down a little bit further to the south and look at Myrtle Beach, for instance. Here, let's go to MYR. They're just getting some light rain right now. They did have some thunderstorms in the vicinity with light rain. And if we go down here further, again, it's showing for the most part convective potential is rather low through this period. So I guess the takeaway of this is to use this kind of properly is when you start seeing convective potentials in the high and very high range or even medium range, there's a really good likelihood that that terminal area is going to see those thunderstorms. And you can actually even see cases where you can see a very high convective potential but a very low or even negligible thunderstorm probability. Again, simply because you might have some really lots of very towering cumulus, congested cumulus all around, producing showery precip in really large areas, or have a high risk of that. But they may be low-topped convection where there's not a lot of lightning potential there as well. So I don't pay a lot of attention to the thunder probability and more associated with the convective potential here and looking at that. So this again tells me that there's definitely going to be some thunderstorms or some convection in that region, but I don't necessarily won't necessarily be such widespread event that I couldn't find a good way to get into that airport. And I may have to wait for a little bit. I may have to take a circuitous route to get around stuff to move through it. And I may, if I go in and set my my settings up, I may be somebody, for instance, in my personal minimums that wants to set my convective potential down here near none and down to kind of very low or low, because I may not want to tolerate any kind of convection at all, so I can set that up. Or if I'm a little bit more generous and I want to go a little bit higher here, so that I'm only triggered by something that essentially is above the low category, I can certainly do that as well. So that's kind of what you're looking for in terms of the ability to look at the overall aspects of convective potential in EZWxBrief. That completes episode 9 of EZWxChat. My name is Dr. Scott Dennstaedt, and as always, enjoy the simplicity of EZWxBrief.